All right. Hello, Connor. Hopefully this video helps you out. For this particular problem that you sent me an email on, it's telling you that the triangle that we're going to be doing is in quadrant 4, and you need to find the cosine of, when given this information, that the sine of theta is negative 24 or 25. So usually what I do is I draw a quadrant, a graph here, and in quadrant 4 I draw my triangle. Now when I draw my triangle, the right angle is always along the x-axis, and here is theta. Now this is important information right here. It tells me that the sine of some angle is equal to opposite over hypotenuse, which then tells me that this is the opposite side and this is the hypotenuse length. So when I go back to my picture here, the opposite of this angle is over here, and it should make sense that it's negative 24 because it's going down. And then the hypotenuse, which is right here, is 25, and that goes right here. Now, the hypotenuse is never negative, so the x and the y-axis can be negative depending on where it's at in this quadrant. And so now that I have this set up, they're asking you to find the cosine of theta. They put a little 1 here. Well, to find the cosine of theta, I need the adjacent side over the hypotenuse side. Well, I need this. So in order for me to find that, I use the Pythagorean theorem. And so we know that the Pythagorean theorem is a squared plus b squared equals c squared. Well, I'll call this a for right now if we want to. Now, I can then go a squared plus b squared is negative 24 squared equals, c is always the hypotenuse side, so make sure you put that in the right spot. So 25 squared. Now, when you do the math for the Pythagorean theorem, you end up getting a squared equals 25 squared minus negative 24 squared. And I believe it equals 625 when you do all this math over here. So then I square root both sides, and I find out that the adjacent side is 7. Sorry, I think I did my math wrong here. I was looking at something else. Let's see here. I do believe that you get a squared equals 49, and therefore a is 7. There we go. That's what I want. Now, that means this side length is 7. And it's positive 7 because it moves in the positive direction for the x-axis. So then now I can come over here and set the cosine of theta. Sorry, I'm getting sloppy here. Cosine theta 1 is equal to the adjacent side, which is 7 over 25. So that is my answer. Hopefully that helps you out. If you have any questions, continue to send me the emails and I'll try to answer them. But when doing these problems, this tells you where to draw your triangle. Make sure that the right angle is always on the x-axis. So when you go to do these problems, your triangles can be in any of these locations. Here, 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 and here. Kind of like a bow tie, where your right angles are always along the x-axis only. We never draw them up here, okay? And then, of course, here, this is going to be a positive side length, positive side length. This will be positive, this will be negative. Here it'll be negative, negative, and positive up here. So when it tells you what quadrant it is in, that's important. It tells you where to place everything. And then it also tells you what side length is going to be positive and what one is going to be negative. Again, the hypotenuse sides are always going to be positive. And then when they give you one of the sine, cosine, or tangent functions, they're actually telling you what are the side lengths of the triangle. This is the opposite side length of the angle that you were given. So opposite over hypotenuse. And then you can use the Pythagorean theorem to find the missing side length, and then you can use it to find all the other trig functions that they could be asking. Hopefully this helps. If not, I can try to find you another video, but let me know. Thanks.